All right, we're going to go over the notes here on 9-4. We're going to actually step away from the 4 types of transformations and just hit a section called symmetry. So, what is symmetry? A figure has symmetry if it maps upon itself. So what does that mean? Well, we'll show that in a moment. It's not going to be super advanced stuff here. There's going to be 2 types of symmetry that we're going to hit. We're going to have reflectional, where something is reflected and it looks exactly the same, or we can rotate it and it will be exactly the same. So here's an example, this heart here. This dash 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 line is called a line of symmetry, and we would call this heart figure symmetrical. It has symmetry because if you just fold the paper right where that heart is, this left side of the heart would match exactly onto the right side. Okay, this heart figure has reflectional symmetry. It can reflect upon itself. Now that doesn't mean you can just draw any line, because this line here, this bottom half, which is more like a triangle, and this top half, which kind of looks like a butt or something, those are not symmetrical. So, and in some of the pictures, literally all you're going to do is see a picture of this heart, and you're just going to draw this line and say this has reflectional symmetry. So that's one of them. Some type of figure that you can just draw a line through it, and everything on the left and right or up and down looks exactly the same. Another one is rotational symmetry. And rotational symmetry is this bizarre looking, I don't know what this thing is, like the letter N, but kind of funky. And if you can rotate that picture, and if it can look exactly the same as when it started, then that would be rotational symmetry. Now, when we rotate it, we're going to talk about any rotation between 0 and 180. Obviously, if you rotate anything like this eraser and rotate it 360 degrees, it looks exactly like it started. But if I take this eraser, which is up and down, if I rotate it 90 degrees, well, it looks different. Now it's pointing this way. If I rotate it 180, it's upside down. I mean, if you're looking at this crazy looking guy here with a hand. So it has to be something that can get rotated between 0 and 180 degrees. So this is like the letter N. If I rotate it 90 degrees, I'm literally taking my paper and rotating it, it looks like the number 2. And so that's not reflectional. But if I rotate it another 90 degrees, it looks exactly like it was, the letter N again. So this has rotational symmetry. And we would say, not only does this have rotational symmetry, we would say it has 180 degree rotation. Okay. Number 1, we're going to draw a rectangle and all the lines of symmetry, which means like this heart, the left and the right look exactly the same. So I want to draw a rectangle. I know I want to kind of make sure it's not as square, so I'm just kind of sketching a rectangle here. And I want to basically, like the heart above it, just draw these lines of symmetry where it perfectly splits it in half like a mirror. And one of them will be this one here, going up and down. The left and the right are exactly the same. There's this one here, going left to right. The top half is the same as the bottom half. And the one that is kind of a maybe is this one here, from corner to corner. Now this one is actually incorrect. And I want to explain why it's incorrect here. It is true that this line at a diagonal splits the rectangle into 2 equal triangles. The shaded triangles are the same, but we're not talking about the same. Would it actually fold right on top of each other? If I put a little dot here, and if I actually folded along this diagonal line, I think this thing would end up somewhere here-ish, this dot part. This X would end up somewhere here-ish. So that, and there's no part of the triangle that matches this right here. So you can't go from corner to corner, so this is actually not a symmetrical line there. Okay? It has to be folded, not just I made 2 congruent triangles. That's not symmetrical. All right, and finally we'll do one more here. Number 2, tell whether the umbrella has rotational symmetry and or reflectional symmetry. Okay, give the degrees and draw the line. All right, well, it depends how you want to look at this picture. If you look at this picture like it's not even an umbrella, we don't even know what an umbrella is, this is some type of two-dimensional piece of paper, some strange looking picture, then this thing has no rotation, because if I rotate it, this little pointy guy is pointed upper right. If I rotate it 90 degrees, now it's pointed this way. If I rotate it another 180, now it's pointed downwards. So if I don't look at this like a three-dimensional umbrella, and I look at it some type of bizarre looking bat wing, it has no rotation. But it does have a line of symmetry, and that would be this line coming right along the stick. Everything on the left can be folded right here on top of the right. So that is one way to look at it. The other way to look at it is, well, what if this is 3D? What if it really is an umbrella? Well, you could rotate the umbrella. You can take it like my pen and just rotate it like this. You got to imagine in the three-dimensional world that the umbrella gets spun around. And so you got to figure out, well, this red little arc here, how many degrees would it take to get to this part of it? And this arc here, how many degrees would it need to rotate to here? You've got to think about this. This umbrella, even though we only see half of it, there's a second half to this. We see one part, two parts, three parts, and there'd be three parts on the other side of this umbrella. So if you think of this as a three-dimensional umbrella, if I rotate anything 360 degrees divided by 6, because there's 6 even parts, 3 that you can see, 3 behind the picture, that's 60 degrees. So every 60 degrees in the three-dimensional world, this thing is rotational. Again, what I mean by that is this yellow line, if I took the umbrella and rotated it 360 degrees, it would end up on this yellow line. And this yellow line would end up here, and so forth. They would just kind of change places.